get started. Hello and welcome to the Why Everyone is Using curl and You Should Too webinar presented by Daniel Stenberg, founder and chief architect of curl. My name's Kristen and I will be moderating the webinar. All attendees will be in listen-only mode. There will be a Q&A session at the end of the presentation, so please feel free to enter any questions into the Q&A box to be addressed during the Q&A time. The webinar will be recorded and made available via link following the presentation. And now, without further ado, I present Daniel.
Hello and welcome. So I'm gonna get right to it. So I'm Daniel Stenberg. I work for Wolf SSL. I've been maintaining curl. I founded a project, started it, and been maintaining it for almost 22 years. I've been doing HTTP programming since a few years before that. So HTTP and client-side HTTP has been my well, interest and hobby for a very long time. So this is what I wanted to talk to you about today. I'm going to start out a little bit about what curl is, who is using curl, why they use curl, who makes curl, and how we make curl, and how we support curl or curl users. And then in the end, a Q&A session. So I'm going to try to go through my presentation and talk a lot of things and hopefully be done within 30 minutes. And then if whatever question you have, fill it in the Q&A tab and we'll get to it in about 30 minutes. So curl is what I call, I often have a problem to explain to regular mortals what curl is, but curl is a client-side command line tool and a library for transferring data using internet protocols specified as URLs, right? The name curl actually came about as client for URLs or possibly C URLs. So it's a play on the URL. So you specify transfer with the URL, curl does it. So, and curl then transfers data using a lot of different protocols. We count them like to be 24, a little bit depending on how you count protocols. But and here are some of the primary ones: file, FTP, FTPS, HTTP, and HTTPS being the most known ones, and the email protocols: IMAP, POP3, SMTP, and also SCP and SFTP. So a lot of different protocols, and the curl makes internet transfers with all or any of them, and more of them as well. I just didn't want to list all of them in a big slide. So curl is open source, and it's been open source since day one. It was started in 1998, and we've been going ever since. It is very liberally open source license. It's an MIT version. It's actually not exactly the MIT license because someone edited it in the beginning, but it's basically MIT. And we support it at Wolf SSL, and I'm at Wolf SSL to do that support, that commercial support. Right, and I'm also the founder of the project and lead developer, and I'll get back to that. So curl has been around for a long time, and it has grown significantly since the beginning. The number of lines of code in the project, we started out at 2K in 1998, and we're at a little bit over 160K now, and growing at a fairly steady rate. Internet protocols and internet protocols with this amount and this amount of features, yeah, it adds up. And at the same time, curl has really became sort of the Swiss Army knife of internet transfers, and in particular than HTTP. And that's sort of also the reason why it has become more code, because it can do a lot of things when it comes to internet transfers and doing the transfers you want the way you want on applications and services need and desire. So curl is widely used. I actually count and estimate that curl is today one of the most widely used software components anywhere. So it's used widely in servers in general, since it comes shipped in basically all Linux distributions, and it's shipped and used in it's a default HTTP transfer library or component in PHP. So it's present in basically all PHP installations, WordPress, in millions and millions and hundreds of millions of web servers, possibly even billions. It is available and used in gaming consoles like this Nintendo Switch is a primary HTTP and internet transfer product, engine there. It is used in lots of various devices. Anything you need and want internet transfer. So in this kitchen blender, it actually uses curl. Smartwatches. And why not other gaming consoles? PlayStation uses curl as in the core OS. Netflix uses curl in all their hardware movie devices, and also other media players, Roku. libcurl is a fundamental piece of transfer technology in a lot of games, like this is the Grand Theft Auto 5 ending sequence, and Fortnite is also a user of curl. So well over half a billion games in game installations uses curl, and it's present in the Apple TV, of course. And I count curl installed in at least 22 different car brands. Basically, all top car brands of the world are using curl in their in-car infotainment systems. And of course, it's been around in Mac OS since well over 15 years and used there by default. It's shipped by Apple. It's used in basically 500 million TVs. It is nowadays installed by default in Windows 10. So it's another billion installations. And it is also used in quite a lot of number of other applications running on Windows, of course. So not only that can be installed in Windows, but a lot of applications like Skype or Spotify, or as I found out just the other day, Backblaze backup software. So a lot of software is using libcurl or curl in Windows as well. And of course, in mobile phones like Apple devices, it's used by default in iOS, and it's used basically in every app, Android phone too. It isn't used by default in the Android by Google, but it's used by all the big applications like Instagram, YouTube, Spotify, and a few Skype and a few others. So a large number of billions of mobile phones use it too. So yeah, a lot of companies are using curl. I once tried to maintain this list of companies using curl, but I actually stopped because it turned out to be so hard and so many companies are using it. So nowadays people tend to ask me which companies that don't use it, but pretty much a huge number of companies are using it. We're estimating today that we have roughly 10 billion installations of curl worldwide. That's kind of interesting since we're only about 4 billion internet users. 2.5 curl installations per internet user on the globe, give or take. One little fun thing I just wanted to sort of insert here too. Since a lot of devices, a lot of things are using curl everywhere, this curl license shows up, and the curl license includes my email address usually. So I get a lot of fun questions just because of this effect. So I get a lot of questions like this, and this is a golden gem. I just wanted to spice everything up. And so this is an email I got from someone who had a Toyota Corolla with a problem with his multimedia system. I have no idea what he's talking about, but it was just a fun thing. He probably found my name then in the car's infotainment system, and about window it usually looks roughly like this. Here's a photo. This isn't a Toyota Corolla, this is a Volkswagen, but anyway, my name is in there and my email address is there, so I get a lot of these very interesting questions. Anyway, so why do all these companies and devices and everyone use curl? 10 billion installations, right? Well, first, of course, you can buy commercial support for it, which is handy. libcurl has a very stable API. We basically have kept the same API. We haven't really done that, but most of the API is exactly the same as we did, as we introduced in 2001. Most of the examples we wrote back in the early 2000s, you can still run exactly that code today with the latest libcurl. And we haven't actually made any backwards compatible changes since 2006. And we make it a really big effort to make sure that we don't break APIs, we don't break behaviors, so you're safe. Even if you upgrade your application from written way back and you upgrade it to the latest libcurl, and you can be sure that it'll behave the same, because curl is stable, the API is stable, and we don't break things like that. We have the same API everywhere, meaning on every operating system you can run curl and on every CPU architecture. So your examples, your code, you can easily move your code over from different operating systems or different generations or whatever. Curl is going to be the same. It'll ship the same API everywhere, and it'll be independent of whatever you run it on. And of course, that's all of this is because curl is open source, it's free, and I call it immortal, but because it doesn't matter if I get run over by a bus tomorrow, curl is there and it'll just keep on going. And that is, of course, appreciated by everyone, because you know that whatever happens, it won't go away just because of anything like that. It is also what I call battle proven now, since we've been using it in production by companies everywhere across the internet for 20 years, something. So we've polished away all the rough corners. It's pretty slick machinery now. It works, and we know how to do it. And it's thanks to it being very widely used, very widely tested, and a lot of eyeballs on the code, it is now also fairly secure. One of the big points with curl, and I'll get back to that in a few minutes, but it is also very customizable. You can pretty much tweak the build and adjust it according to your own desires. All of these device manufacturers, if you want to build your watch or fridge or kitchen utensil, you can customize your particular libcurl build for that purpose and get it more exactly streamlined for your own purposes. We have been working with these internet protocols for a long time in curl. So, internet protocols is a fun thing because they're all specified, they have documentation, and you know how they should be done because it's all documented, right? But that's not really the truth, because out in the wild on the internet, you actually have to adjust, because implementation server side and other clients, they don't actually follow the specifications all the time. So we have to, well, give it time, adjust to how the reality actually works. And that, given a lot of time, a lot of hours, and a lot of people and a lot of users, we can sort of polish away all the bad stuff and make it actually work the way it's supposed to work. The way curl supports many protocols is also actually appreciated by a lot of users. Half of all libcurl users use more than 2 protocols. So the fact that it supports ATP and HTTPS and a bunch of other protocols is much appreciated. And not the least, curl keeps up with internet development and protocol development, right? So we're ahead of things. We support the latest TLS versions. We support the latest HTTP versions. We were very early on with HTTP 2. We're already on track with HTTP 3. We're going to continue be sort of on the bleeding edge of protocol development to make sure that we have that Swiss Army knife for internet protocols, even if you want to use the very latest of protocol versions, or go conservative with whatever worked 5 or 10 years ago. We'll keep covering the entire scale of functionality. So you can customize curl quite a lot, mostly at build time, of course, but quite a lot at runtime as well. But if you do it at build time, you can really streamline it for your needs. And I just wanted to highlight 3 different ways that you can do it. For example, you can do the tiny curl route that we've introduced the last year. You can get curl to use FIPS or FIPS-ready libraries, and you can completely configure the build. The tiny curl is a little effort we've done to make sure that you can get because I showed you the graph of the number of lines of code in curl, and it has grown from 2K to 160K lines. And of course, that's a lot of code now. And if you build a lot of features and a lot of protocols, it becomes somewhat larger footprint, of course. Maybe that's not suitable for your embedded system and you have a limited use or blah, 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 whatever. And then that's why we started this tiny curl effort, which is a way to really streamline your curl build to make sure that you get it as small curl as possible for HTTP transfers only. And we've then aimed to do that with wolfSSL, because wolfSSL is a TLS library really suitable for small footprint builds, and we've aimed and we've managed to get those two combined in less than 100K file size on a 32-bit ARM architectures. So that was the goal, and we've accomplished that. So that you can get a really tiny, maybe not tiny in everyone's definition of the world, but in the curl world, 100K is a small footprint. Yeah, and we ported that to FreeRTOS, which isn't actually supported by the regular curl yet. And of course, you can get this supported by wolfSSL if you would go that route. And another configuration thing is, of course, you can go the FIPS-ready route. Since with curl, you can customize and build it with whatever TLS backend you want, basically. We support today 14 different TLS libraries. So whatever device or service you build and you want to have curl with your particular TLS library supported, we can do that. But of course, if you want to go with a FIPS or FIPS-ready route, you need to build with a TLS library that is FIPS compatible and ready, and one of them being wolfSSL, and of course curl supports wolfSSL perfectly well, so you can pick that backend and you will get a FIPS-ready build with, again, the same API as otherwise, always the same API, and you would get that supported by wolfSSL, particularly then if you would use the wolfSSL TLS library, because then you get a sort of full wolfSSL bingo scorecard. So, but otherwise, yeah, you can configure it a lot. You can pretty much cherry pick individual features or disable, enable a lot of different things to remove or add whatever feature you need in the curl build. Not whatever feature, but a lot of different features. You can select on and off, and a lot of third-party libraries. You can actually build curl with up to 32 different third-party libraries, and all of them are pretty much on and off. You can select which one you want and which one you don't want. So you go with what features and functionality you want in your libcurl, and you enable that in the build. And thanks, of course, to a lot of time and this being open source, and we've done the job already, it is easily ported to additional operating systems. If you have an operating system that for some reason isn't already supported by curl, it is fairly easy to just bring it to another operating system, as long as it's sort of not done in the 80s or is extremely weird. And again, it's still using the same API. Whatever you do, even if you cherry pick different features and you go to different operating systems, it's going to stick with the same API. You can rerun the same application code. Of course, if you disable features and one of the APIs happen to need that feature, the function won't work, but the API is still the same, right? And of course, we support this at wolfSSL too, whatever you do with your build. So just to show you a bunch of different features that you can actually switch on and off in the libcurl build. These are pretty much, these are 16 different features that you can switch off if you want to. I think they all are enabled by default. Just showing that you don't need to care about all the details right now, just showing that there's a lot of features you can switch on and off. And if you do, you can also then manage to get curl running on a lot of different operating systems. Like we have this, I'm pretty satisfied that I finally got this square grid now that's even 72 boxes with operating systems that curl has or is running on. It has run or is running today on, and that people have reported that they have used, or I have found out that they have used. So it is widely portable, widely available everywhere. And of course, you can run it on any CPU architecture you want. Pretty much the only limitation here is that they're all 32-bit or bigger. So it's actually not ready right now for 16-bit CPUs. Possibly we could do that too at some point. So basically, any operating system, any CPU architecture, curl has already been there. So how do we do this in the curl project? So first, of course, I just wanted to show you that I once made this list of the 133 most relevant RFCs, the specification for the protocols curl supports. all those transfer protocols and the related things. So if you read all these RFCs, you know how to implement all them yourself. And I'm not saying that we all did that in the curl project. I just found it fascinating with the amount of information that you actually need to comprehend to do some stuff like that. And all of this added together ends up 1.3 million words in these specifications, those 133 RFCs, which then ends up in this slide. You can compare them to the Harry Potter series books and the Lord of the Rings series, including The Hobbit. So it's a little bit over one Harry Potter series. I think it's 7 books, right? So yeah, and War and Peace is nothing in comparison. A lot of words in the specifications. So curl is open source. We have as you just saw the graph before, we have over 2,000 contributors to the project over the years. Contributors being basically anyone who has helped out. Bug reports, written code, suggested features, maybe not so much that, but helped out really, came with good advice. 2,000 people, and out of those, about 750 people have actually written code that we've merged into the repository over the years, out of which about 150 of them do this every year. So we're around 150 unique authors per year, but we're also about 10, 12 people who actually do more than 10 changes per year. And out of all those 10 to 12 people who do 10 changes per year, it's me doing more than 10 changes every year since 1998. So, oh, right, I completely forgot I didn't show you this before, but this is a number of contributors in the project over the years since I basically started collecting information, which is back in 2005 on the left side, and all the way up to this latest release actually, which was done last week. So, and we're approaching 2,100 right now. So as you can see, it's a pretty steady growth. We're adding a few hundred new names every year. So it's growing pretty rapidly. And I think it's a testament that the project works pretty good when people can still contribute, and we still get newbies to contribute and add code in every release, and it's great fun. My share of all these commits, of course, I started out, as here you can see in the beginning on the left side of the graphs here, I did all of the changes in the beginning of the project. And as you can see, people have contributed, so 750 authors, I'm one of them. But as you can see, I'm still ahead of the majority. I've still done more than half of all the changes in curl accumulated. But it's shrinking over time. So I don't think it's a goal for me to keep this high level of participation, but I enjoy it. I think it's fun, and I'm going to keep at it. So we do releases every 8 weeks these days. We've done 188 releases since 1998. So we do them on a regular basis, like a clockwork, just 50 to 60 contributors in every release, give or take. Sometimes it's 40, sometimes it's 70. We're usually around 40 people, 30 people writing code in each release for all these 8-week cycle then. And we usually have newbies in every release, new contributors, new code authors in every release. And a release for us is source code only. We ship a new tarball, and as you know, I mean, if you use curl on Windows, on Linux, on Mac, or wherever, you don't use the source code, right? You usually get it from somewhere. If you're having a Linux distro, you install it from your distro. If you run it on Linux, you just have it, on Windows, you just have it in Windows 10 or blah, blah, blah. But of course, that's because they are building it from the source code we ship. So it works pretty good. We ship the source code, they build the binaries and ship to their users. So we're usually handing out that responsibility. So how do we do this secure and safe enough for the billions? So we start out, of course, with reviewing code, and we have a pretty, I would say, we're pretty strict on the code style. We document a lot. We have a lot of documentation on how our APIs work, how our code works. So it's should be easy to understand and do the right thing. We have a lot of tests. We test everything, and we try to test as much as possible. We CI like crazy. We do, I think, around 60, 70 builds now per commit, per pull request, to make sure that whatever we merge is good. Of course, we still do mistakes, but we're constantly adding up here. We use Valgrind and sanitizers as much as possible in builds and tests, so we know that we're merging good stuff. We don't, well, as good as possible. We use several different static code analyzers. On all, not everything on every commit, but regularly at least, so we make sure that we fix everything. We are part of the OSS fuzzing project by Google, and we do other fuzzing or fuzzing efforts, and people run fuzzers, so we're pretty good at catching even those kinds of mistakes. And we had an external code audit a few years ago by Cure 53 of Germany. They found a few flaws, but still they made sure that we've sort of added our game, improved our game a little bit, and we have a bug bounty that rewards people who report security problems. We actually rewarded one recently in the recent release, and we're actually now trying to up our reward amounts in that bounty program going forward. So we're at 90 something CVEs, but I think 90 CVEs over 22 years is not that bad. So of course, we fix all warnings we have in the build. We fix all defects that code analyzers and static analyzers find. And of course, we build everything with the most picky compiler options possible to make sure that we detect all the mistakes we can get with the compilers and lints and everything, and test everything, as I said, and we fix security problems as soon as we can. And we support our users, of course, in the open source way and the open source style, because we do everything on GitHub. So we have issues and pull requests there. Everything's there in the open. If you want to discuss things, ask questions, come with brainstorm ideas. We're an old style project, so we have mailing lists. We have mailing lists both for the command line tool and from the library, 2 different ones. And of course, we do security issues directly in HackerOne these days for the bug bounty, and to make sure that we keep security problems non-disclosed while working on them, so that we can disclose them responsibly to people when we have a fix and we release a fixed version. And of course, there's a lot of discussions users to users on things like Stack Overflow. Stack Overflow now has almost 40,000 questions marked tagged curl. And of course, we support commercially whoever want to have commercial support and private help or whatever. We support it at wolfSSL if the open approach is not good enough. We usually have this roadmap in curl, which is very vague, and it usually looks about like this. Bam. We don't really know what to add. We will add stuff over time, and it'll be good. It'll be more over time. We're an open source project, and basically I'm the only one working at curl full time, so we don't really know how to plan what we will add, because who knows who will show up next week and what they will bring to the curl project. But that said, the roadmap of curl also then makes it really configurable. So whatever you want to do, whoever user want to do in the project, it is on demand, right? You can bring a patch tomorrow, or come suggest something, or offer us a deal, and make sure that we work on that feature or that thing now or tomorrow or whatever. And it's also a lot of people just show up, with a pull request, and here, look at this feature that I think we should do. If it's fine and it's a good idea, let's do it. So yeah, we can do private development, of course, and we can merge them upstream or not. And I'm going to do a separate webinar on the curl 2020 roadmap from my point of view, or I would possibly say from the wolfSSL point of view, of what I and wolfSSL is going to work on for curl in 2020, because I have a rough idea, and it's I'm open for input there, of course, depending on what you would like to see and what kind of internet transfers and transport stuff you think we should do. I'll get back with some details about when that is going to happen. But in the near term, I think within weeks or a month at least, we should do that. And whatever you want to do, of course, to configure the future of curl, we support that at wolfSSL. So if you want to read more about curl or learn more about curl, we are of course on the curl website, curl.hacks.se, and the other, here's the link about on the wolfSSL site on the curl product if you're interested in the wolfSSL commercial angle to curl, and that's the email you address to email for support. Thank you for listening. That was my really quick, I feel, run through the curl project, what we do, and how it works and why people are using it. So I can see that we got a question. So if you have more questions than the single one, go ahead and fill in. So I'm going to go through the questions. I see 2 questions. I'm going to answer the first one just live here, so I don't have to type. Currently, I have MQTT using wolfSSL commercial version. Now to support HTTPS, planning to integrate TinyCurl over existing wolfSSL. What modules require? You know, the TinyCurl thing is for HTTPS transfers using wolfSSL. So it doesn't really replace wolfSSL there. It's using wolfSSL. So the TinyCurl is basically the smallest possible way to get HTTPS transfers. So you would use wolfSSL for that as well to get that going. Basically a build with curl with wolfSSL, that combo. So that's what you need, curl and wolfSSL, and do the build the right way, of course. So if I'm using any fuzzing tools to test the security of curl, yes, we do. So we primarily do our fuzzing with the OSS fuzz project style that Google is running. So Google is putting a lot of machinery and they actually run fuzzing on curl code nonstop, you know, on Google infrastructure. So they do it all the time, and we have we sort of hooked in our few functions to help that fuzzer fuzz our code as good as possible, so it keeps fuzzing. And fuzzing is awesome when the static code analyzers find nothing, when you're down to 0 defects everywhere, no lints are happy, then you start getting the fuzzers in and they find issues, right? And we found a lot of issues initially when we did the fuzzing, but the fuzzing nowadays is going and going and going, and it's very rarely finding problems because we sort of polished away most of it. And now if we introduce a problem, the fuzzers find them almost instantly. So yes, we have fuzzers and they find things. So usually they find them immediately after we merged a stupid commit. So they very rarely go into final releases. Of course, it still happens. And then we have a bunch of, I know a few of these security researchers that are usually on reporting to us, they have their own fuzzers too. So we have the automated ones. We have a small one in the CI that runs a very basic fuzzing on every commit. But so yes, we have a range of different fuzzers going. Use cases why I should investigate integrating curl over other methods. Well, yeah, curl is not really, I would say curl is a fantastic and established engine for doing internet transfers using these established protocols. So if you want to do if you want your product, your service, your application to safely and securely transfer data over one of these protocols, like all of these are doing HTTPS these days, really. Download, upload, submitting, you want to have cookies, you want to do TLS safely, you want to have all that, then curl is a really solid way to do that. And it's not the only option out there, but it's going to be the only option for you if you want to build your smaller devices on different operating systems with these different protocols, and you want to have an API that you know will exist and be reliable for another 10 years, and you know it's going to be there. Not a lot of others can guarantee that and promise that, and have that track record proving that it actually works like this. So how many operating systems are included in regular testing? Too few, I would say. We have, well, of course, we have the major ones. So we do everything on Linux, Mac, Windows, FreeBSD, Solaris, and yeah, I would say those are the 5 primary operating systems. And we do on a few different CPUs too. So we do them on Intel, and we do them on ARM. But yeah, and then we go more rarely on other operating systems, because then we have a more of a resource question, what systems are around, since then we rely on volunteers and to run the test suites for us and submit the results back. So we've had others and on and off, depending on which volunteers are around. Usually, however, since curl is very portable, we usually and mostly run the same code on all those different platforms. So usually it doesn't matter that much, because if it turns out that it runs fine in all these operating systems on all these different CPUs, it tends to also work on the others. But of course, it is certainly an area that might cause us problems sometimes. There's also this problem that, as I mentioned several times here, that we have a lot of different build combinations, and you can build features on and off. So of course we can't test all of those different build combinations on all of these different operating systems and all of these different CPU architectures. It's just not possible. We have to make it a sensible sort of judgment call. What do we test to make sure that we do the best possible coverage, to make sure that we're fairly sort of happy with it, and we feel fairly secure and safe that this actually works. But I would say that given how it has fared this far, I think we usually end up managing it pretty okay. So, okay, right. Keep asking if you have questions. So, why should I use curl via HTTPS instead of the post method? Well, curl is just the engine, right? It does HTTPS. You can do post. Curl can do whatever HTTPS you want to do, whatever HTTP transfer, get, post, delete, put, patch, or whatever you want to do. Curl can do it. So it's not that it doesn't replace or change post. If you want to do a HTTP post from your application or your device, curl is very good at it. So you could use curl to do it. You can do it from a command line, or you can do the API wise. It's up to you. It is HTTP and HTTPS they might look like simple protocols from the outside, or reading the initial protocols and looking at the initial headers and stuff like that. But they're really fairly complicated protocols to make sure that they actually work against all those servers, through proxies, through different networks, through different behaviors. So it takes time and effort to make sure that you actually do HTTP the way that actually works on all these different places. And we've taken that time already. So curl is there and it works and it runs already. And it's free and available. You can just run it and try it. And if it works for you, it works. And if it doesn't work, you can fix it, or someone can fix it for you, or you can ask someone to get you help. So I'm doing this from my home, so you might have heard my kids in the background. So I'm not getting any more questions here, which seems okay. Are we done for today?
I think so. I'll just remind everyone if you have questions, feel free to email us at support@wolfssl.com. Thank you, Daniel, for the presentation. The link will be posted once, the link will be sent once we've got it posted up on our YouTube site. And unless there are any other questions, thanks very much.
Thank you, everyone. Bye.